Okay, cool. So I believe that I am live, right? And I also believe that you guys can hear me and can see my screen as well. Great. If you guys can hear me properly and if my screen is also clearly visible, do let me know in the chat sections. Yeah. Great. Hello, 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 everyone. Yeah, hello, Abhi, vlogger. Hello, Ganesh, and hello, Ramesh. Yeah, cool, great. And I hope that the voice is also clear and you can hear me crystal clear, right? Chalo, cool. So we will be waiting for, until 6:05, so that everyone can join in and everyone can get this notification and they can join in. Till then, you can tell in the chat sections ki if you are joining this bootcamp for the first time or not, or maybe 3 days. I've already been 3 days. It's been 3 days since we have started this bootcamp, and we have covered 2-3 topics as well, right? 2-3 important topics. So yeah, tell us that if this is your first time joining in for the bootcamp, or you have been joining earlier as well, right? Chalo, cool. And meanwhile, you can also introduce yourself, like, yeah, I'm from this college, this branch, or this department, anything. Great, third day. Cool, cool. Thanks, happiness. Yeah, I remember you joining in the initial sessions as well. Yeah. Good evening. Hello, Evan. Okay. Hello, Abhishek. So see, majority of our audience, and I believe English is generally everyone can understand, right? Because many people are tuning in from South as well. So that is why we'll try to communicate in English only. But yeah, at some points don't worry, मैं कुछ कुछ पॉइंट बीच में जो होंगे उसको हिंदी में भी एक्सप्लेन कर दूंगा, सो दैट सब कंफर्टेबल फील कर. ठीक है. Great. uh, we have GK asking this question ki the difference between radix set sort and count sort. Okay, so see, we are not will not be discussing about every sorting techniques right now, because see, every technique requires different techniques require different methods. So we'll only be having brief discussion about some of the sorting algorithm. Let me tell you what all sorting algorithms we'll be dealing right here. Right. So right now, in today's session, we'll only be taking questions in that domain only. Right. And don't worry, maybe if in the later stages, right, as we cover all these topics that are required, all these things that are required for learning all other sorting algorithms as well, we'll also cover that, right? Don't worry about that. Yeah, hello, Psycho Creations. Yeah, great. You also joining in for the third day. Great. Okay, hello, Kajal Saini. It's your first day. Great, cool. Anyways, is Inzer employee? Okay, yes, I remember you telling that you were some employee happiness. Yeah. Okay, I'm okay. We are from Nepal, I guess. Yeah. Great, cool. Thanks everyone for joining in. Right. We'll be waiting for 1 or 2 more minutes, right, so that everyone can join in. And once we have some concurrent audience, then we can start, right? Cool. And also, for those of you who had joined the yesterday session, there was a disturbance, right? There was some audio discussion disturbance or something because of maybe my mic got broke or something. But today it is fixed, and we would like to apologize for yesterday's session as well. Yeah, because I feel like you might have encountered some trouble. But yeah, anyways. Yeah, hello, good evening, Sutendra, right? Sorry if I'm not pronouncing your name correctly. Yeah, and Sunam Moti Sai Ganesh, yeah, hello. Yeah, hello, Chandra as well. Hello, everyone. Yeah, great, everyone. Cool. So it's been 6 to 5, right? Chalo. I think we should start, right? And so that we can have some time to ask, to resolve your doubts and all. So, yeah, let's start with the very first thing that is, yeah. So let's start with the very first thing that is arrays, right? Arrays and sorting techniques we'll be covering in today's session. So before going into sorting techniques, we need to know what are arrays, right? So arrays, okay, let's take a scenario, right? Let's just a minute. Cool. Yeah, let's take a scenario where let me open up my whiteboard so that I can explain everything over here, because writing in that area is a very limited thing, right? There is very limited area to write over there. So I'll, first of all, there is no need of this pen. Cool. So what I was telling is, suppose let's take a scenario, right? You know about data types, you know about variables and all now. So let's take a scenario. If you have 50 students, right? If you want to store name of all those 50 students, so you practically here, if you have to store name of one student, what you will do? You will create a variable, maybe call it as a name. If you want to store your name over here, right? Now if you want to save another name, right? Maybe some of your friends' name as well. So you'll create another variable and you'll name it as name 2, right? This is variable 1. This is variable 2. Or maybe if you want, you can give this a name 1 and you can give this a name 2, right? Now what will happen if I have to create like 10 students, 20 students name? If I have to store 10, 20 students name, right? So creating 10, 20 different variables will be a very hectic task, right? Why hectic task? Because, you know, how will you remember name of all of them, right? And 10 is a very simple number, right? 10 is a very small number. But if you have to store like 100 of such students, so that is practically not possible, right? And obviously it will take some memory, we know, but this is not the efficient way of writing that, right? So if you have to deal with the large number of data that is relevant, right? Or that is, that is related to each other or something, right? Or that is of the same format for a reason, you can say that naming variable differently is not a solution for that, right? This is not a better solution. So what can be the better solution of that would be, suppose if I want to store name of all the students of my class, or maybe suppose if I want to store all of my friends' name, right? Suppose if I'm very social person, right? I have tens of such friends. I have 10, 20 friends. I want to store name of each of those students into some variables, right? So how will I do that? I'll not create 10 variables or 20 variables for them. Rather than doing that, what could be the best solution is, what if I can have a bigger box, right? I can have, instead of having small boxes, I can have some bigger box wherein I can place name of all my friends or all my classmates, right? And I can, rather than naming these boxes alone, what if I can name the whole box, right? I can say friends name whatsoever, right? So this will be a better solution, right? Why better solution? Because I'll not have to create multiple, 10, 20 such boxes. Instead, I'll create one box only, and inside that I can access all my friends, right? This sounds like a cool solution, right? Now, if this layman terms is, understandable to you, if this thing is very, very clear to you, now you can say that if we are doing this thing, right? If we are making such things, these things are generally called as arrays, right? This is what we have made. We have made an array, right? In array, if I talk about the technical definition of array, the technical definition of an array is array is a group of similar data types, right, that have contiguous memories, right? Now this contiguous memories wala part might be not very clear to you, but see, if you are storing all these smaller boxes, if you are suppose if you have a friend name A, if you have a friend name B, if you have a friend name C, D and E, right, so on. Now if you want to take out this C names, right, how will you be able to take this name? Right, you cannot say na ki acha go inside friend's name and search if there is someone called C or not, right? So there should be a particular way of doing that, right? So what is the way of doing that is you you access this name, you first of all say friend name, right? And then you'll be using some indexes, right? Indexes bole to you'll not name each of them separately, right? If you have to say again, if you have to say box number A, box number B, then what will be the point of doing that, right? We want is you don't have to create these smaller boxes, right, with separate names. So instead of doing that, what we will do is we will do this one thing, right? We will write a number right inside this rectangular boxes, and whatever number we will write, this box particular corresponding to that number will be given to us, right? Or we can be will be able to track that box, right? Now there is a catch. There is a very little catch whenever we talk about such thing. Suppose if I write 1 over here, right? So that will not point my address. That will not point my address. Just a minute. Let's take some other color. Yeah. Oh, okay. Yeah. Let's take this color. Now this will not point to A's box, right? Why this will not point is कि arrays are generally zeroth base indexed, right? Zeroth base indexes बोले तो the first value that you have is not the first value, but it's a zeroth value, right? You might have also come across some memes saying कि programmers don't start with 1, programmers start with zeros, right? So people might be saying अच्छा this is my day 0, right? Instead of saying this is my day 1. Right, so this is another thing that they take in consideration. The first value that you have inside an array is not the value 1, that is a value 0. Right, I know that these things might not be very clear to those persons who are joining in for the very first time and who are just listening about the arrays and these variables for the first time. But yeah, this is a general introduction, right? I've given you a layman what do you say, a layman definition or a layman description about it. Now it's time to dive deeper into the technical definition, and let's look into the working, how are values placed, what is the meaning of contiguous memory and other things, right? Yeah, exactly. Ganesh is correct. He's saying that continuous or contiguous memory bole to one after another, right? See, there is one other, let me explain that further. Suppose if you have some smaller boxes, right? If you have these smaller boxes, box number A, box number B, box number C, or let's call it 0th, first, second, right, third box, and these values are these variables are enclosed under a variable, let's call it a ARR, right? Now if I want to access them, right, suppose if this box is at this place, if this box is at some other places, how will I be able to track those boxes, right? So the obvious thing that happens when we are talking about arrays, all these boxes are arranged one by one, right? The 0th block is at the first position, then the first block is at the second position, the second block is at third position, and so on, right? So whenever I want to access the 0th box, what I will do, I will write ARR of 0. That will give me the first box, right? I've already told you this. This will point me to this variable, right? If I write this, if I write ARR of 3, what it will point me to? Can you guess? 0, 1, 2, 3. Right, so this will point me to this block. So this is the description of arrays, and this is how we track it, and this is what is the need of array, right? Now I hope that in layman terms everyone is clear with what is the need of using arrays and why do we need arrays, right? Yeah, hello Ashutosh, good evening. Yeah, okay. So now let's do one thing. Let's quickly jump into our code editors. What was it? Online, yeah. And let's see this in working, right? Because unless and until, yeah, it's okay, yeah, it's okay, Ashutosh. Right now, because unless and until we do something, we are not sure about how does this work, right? So let's see this in action and let's find out what is the way of doing that, right? I'll do one thing. I'll quickly, first of all, if I create what, maybe if I want to, suppose I don't want to store some names now, right? Let's make it simple. I want to store some marks, right? I want to store marks of whole my class only, right? So I have to like marks 1, I'll write here. I'll give like, suppose I got 100 marks, right? Then I'll copy these things again and again, right? Sometimes I'll just change the variable value here, right? I'll say marks 3, sorry, and I'll write marks 4 and also on, right? So this is not the efficient way of doing that, right? Maybe someone has got 10, maybe someone has got 90, maybe someone has got like 95 or 80, like. So the catch over here, this is not the efficient version of doing that, right? So instead of doing that, what we do is we create arrays, right? So the syntax of creating an array is, first of all, how do you create a syntax? How do you create an array? Syntax of creating array, right? Or writing an array is, you write int, or maybe you write the type of variable that, I mean the type of array that you want, right? See, array can be of different types, right? You can store multiple integer values side by side, you can store multiple character values side by side, you can store multiple boolean values, other things as well, right? So suppose if you are just taking the integers value, so how will I do that? I'll say the data type, typ data type, then I'll write what, the name, right? The name of array that I want to create. Then I'll write this square boxes, right? Inside the square boxes, see, whenever you are creating a bigger box and whenever you are trying to put some smaller box inside that, you always have to give how many smaller boxes you want inside, right? How many smaller sub values you want inside it. So we'll give number of what? Number of boxes, right? Maybe this is in the layman term, right? The size of the array, what you can write, size of array, right? So if you write it this way, then a box will be created, right? And inside each box, I mean, for each box, you will have this much smaller boxes, right? So what, yeah, exactly, float, etc. Yeah. Exactly, man, Ganesh, you are very right. And see, linked list is also a thing, but in linked list, what happens is that these values may in arrays, these values are in the continuous spaces, right? I mean, one after another. But linked list, the main difference is that the values are not in the continuous space. Second is that in this arrays, these memories are allocated whenever, as soon as we write them, right? Before I mean when I program runs, we have the specific number of boxes. But with linked list, what can we do is, what else extra can we do is we can create extra boxes, we can reduce boxes at the runtime also, right? Whenever we are running something at that moment. Just a minute, what is not, yes, so I'll do one thing. Yeah, now with this statement, what will happen is just a minute, this Epic Pen is giving me some problems. Cool. Right, what I was saying over here is, yeah, if I want to write this, so I'll have an array box. Okay, let's keep this aside. It's causing some problems. Yeah. So what will happen after this is, we'll write, maybe suppose create int, and then we can write it a name, right? Generally, you'll find people writing it as ARR, because obviously ARR is you can write as a short form for array, or maybe if I want to write it as marks, right? If I want to write as marks, I'll write it, and inside that, what I will do is I'll give the size of the array, right? Suppose if I want to store 10 marks, or maybe let's for a moment store 5 marks only, right? So what will happen after this is my 5 boxes will be created in my memory, right? Just a minute, let me show you over here. Right, 5 boxes will be created in my memory, such a way that let me show you that. See, 1 box, 2 box, 3 box, 4 box, and 5 box, right? Now this outer covering will be called as what? This outer covering will be called as marks, right? And all these value, how can I access them? If I want to access the first value, what will I write? I'll write marks of 0. If I want to access this value, how will I write? Marks of 1, right? Similar fashion, you know what is the meaning of doing that, right? Now the catch over here this thing is although very obvious now, but the catch over here is the last index, right? This position will be the size -1 always, right? Why size -1? Anyone can guess, although this is very intuitive and very obvious, because the array is starting from 0th base indexing, right? 0th index. So that is why the last index that you can access is the size -1, right? So let's see this in action, right? So if I've created an array, now I want to access, now I want to give this some values, right? So how can I give this some values? You can give this value at same line here as well, right? You can write this way. You can write what? Suppose the first student got 100 marks, the second got the 90 marks, third one got 80, then maybe someone just passed and they got 33, right? 4 values are already there, and someone got 50, right? So now what will happen is, yeah, exactly, Rohit, you are also right. Ganesh, you are also right. Yeah, everyone is right? Cool. So now what happens is we have filled out these values over these boxes, right? The first value is 100, 90, 80, 50, whatsoever, right? Now the obvious answer is now if I want to access any particular value, how will I get it? I'll get these values by writing this statement only. I'll write C out marks of what? Marks of like, suppose if I want to get the marks the third person is having. So one thing is I need to zoom in thoda sa. Yeah. Right. I hope this thing is clear to everyone. Right. Sorry, I forgot to zoom this earlier. Right. I hope this is visible to everyone now. Okay. Now, if this is visible, let's try running it. Right. Now you can see that we are getting 33. Right. Why 33, not 80? Again, you know the answer, right? The indexes are 0 based. So that is why 33. Now let's do one thing, right? Let's take a risk and let's see if I write 5 over here, what will happen? Right. Now you can, I mean, everyone here knows that 5 is not a valid index over there, right? Let's try doing this and let's see what thing will happen, right? Now you see that it is giving me first thing, it is giving me some random values, right? Why this is happening is sometimes in C++, C++ has some garbage values with you. So that is why it is what it is showing. But in many cases, what will happen is, depends upon compiler to compiler, it will throw an error, right? It will say that marks of 5 is not defined or something. Space is not allowed. Where space is not allowed, man? Acha, if you are talking about this space only, right? Marks space 5, this. See, this is I think a misconception, right? Because I first of all, I'm not very sure about this. This C++ syntax, because I majorly code in Java and all. In that also, you can give a space. It is not a problem, right? You can see it is working. Also, one more thing is, I'm not sure if this will work on C++ or not. Let's give it a shot and let's try. Okay, this is not allowed over here. You cannot write it in front, but yeah. Okay, spaces are allowed, right? It's a misconception that spaces is not allowed. And inside that also, if you are talking about key after giving a comma, then if I'm giving a space, it is not allowed, then it is also not a thing, right? You can give a space properly. This works in Java, this works in Java, JavaScript as well, right? So this will not give any error, right? As far as I know. Right, if I run this again, then I will get 50, right? Why 50? Because the last index is 50. Right, now you can see this. So this is basically about arrays, right? Now you also know how do you access a particular value at index, right? You access the particular value by writing that index, right? So what if I tell you that we have covered so many things with our PPT without even looking at our PPT, right? First thing is index, so you already know, right? Second thing is introduction to arrays, we already told. I already told you, right? If you want to get into the technical definition of that, you can read out from this PPT. Although if you know the implementation, then I don't think you need to know the technical terms. Next thing is okay. Now, what is the advantage of using arrays, right? Advantage of using arrays, you already know that, right? If you want to randomly access any element, right? Randomly access any element, if you want to reach at the third element, if you want to reach at the fourth element, or if you want to reach at the first element, you can directly do that, right? How you can directly do that? Just by tapping into that number, right? Now, the next obvious advantage is you have to write very you have to write very less lines. Because why very less lines? Because see, if you create 10 such variables, then that will be a problem. What you are doing is you are writing all these 10 variables inside one array in one single line, right? Again, the next answer is easily you can access every element just by writing that index. Now, there are some problems with arrays as well, right? Array is not the best data structure, or not the best thing that ever happens to C++. So the disadvantages are it allows only fixed numbers of arrays. Fixed numbers of elements, right? Suppose if you have entered I want only marks of 10 students, right? If you have given this size as 10, you cannot enter the marks. You cannot enter values more than 10, right? You can only enter values up till 10, right? 0 se leke 9 tak or 1 se leke 10 tak you can enter. You cannot enter much values after that. Right. If you want to enter much value, what you have to do is you have to change the size of the array, right? And one more thing is that it is not dynamic, right? Dynamic means, suppose if I'm running the program, right? I have given my array ka size as 5, and now I'm running and I thought I will need like some more spaces, right? I will need 4 or 5 more spaces. I cannot do that while my program is running, right? I have to work with 5 spaces only. Okay, so this is one problem with that. Now another problem that you will encounter whenever you'll start doing some questions with it is ki, suppose if you want to insert any value at an at array, right? So, or if you want to delete any particular value from array, one problem that you will face is ki, suppose let's see this over here, then you'll have a better understanding ki what will be the problem that you might encounter with. Ki, suppose if you have this array, right? If you have this array and if you have some boxes, this and this right now, let's take this only, right? Now if you want to delete this particular box, right? If you want to delete this particular from array, now if you just remove it, will this work or not? Right, this will not work. Why? Because there is a vacant space inside, I mean inside this array. Now you cannot do that ki, you can only say 0 value, second value and third value, and one value is not there, right? So if you are deleting some elements, right, from any particular area, what you have to do is you have to shift those values as well, right? You have to move this value over here, then this value over here, right, in order to make your array look perfect, right? Again, now you'll say what if I want to delete values from the last only, right? You can do that, I mean there is no problem with that, but the thing is ki, you will not always delete value from end. Nah, there might be cases when you want to delete values from the middle or from the start itself. So this is one problem. Again, similar problem is that ki, suppose if this is the array, right? If this is our array, and if I want to push a particular value at this index, right? If I want to add a particular value over here, what I'll have to do? I'll have to add another box over here and fit it over here, right? So this is a task that is cumbersome, right? And which will take much space, which will take much time to do. So this is a disadvantage of that. Yeah, exactly. Such space is not allowed during. Achha, that was be right. Okay. Now Ganesh is saying we can not exactly. This is a major problem. We cannot increase or decrease the size of the array during runtime. Right. This is the major problem. And again, I told you that insertion and deletion are cumbersome tasks over here. Okay, so these are the basic advantages and disadvantages of what? Of your arrays, right? Now let's move on and see its basic thing. How do you write arrays in C++, right? I have already told you this. I have given you the demonstration of that, right? Again, the next point is what? Just a minute, let's run it only. Yeah, the next point is what? How do you declare these values, right? All these things I've already done, right? Now by specifying a particular number and all, right? See, these are different ways of writing that, right? If you look at this very closely, you can see that if you're just giving the values, there is no need of specifying the size, right? If you don't specify the size, your array will take only the size that is I mean that are the total number of values that are present over here, right? Cool. Now one more thing is I've already told you, if you have any variable that has particular value, right? If at this point you see n has value as 10, and what you are doing is you are giving the size as n, right? So it will take that value from here and it will create an array of size 10. Cool. Chalo, so these are different ways of doing that. Now there is one thing, right? What are the time complexities of array operations, right? Although see, if you look at these parts, you can see that there is some different terminologies written over here, root n or n plus root n, all things like that. So these are very practical cases, right? But we don't take these values. Why don't we take these values? Because we take the values that I mean we neglect the smaller values, right? So that is why, assumingly, I mean if I want to access any particular ith element or any particular element, what I'll do is I can do that in constant time. Why constant time? Because I just have to write that number, I mean I just have to write that index and I'll be there. Now if I want to traverse my array, right? So I mean this is the very intuitive, everyone knows here, if this is our array, this is not working in this sense. Yeah, so if this is our array, right, 1 2 3 and all these things are there, right? And if I want to go from this point till this point, how will I do that? How will I have to traverse all these n elements, so that is why the traversing time complexity is n. Now if I want to change any particular value, just a minute, let me show you that as well. Just a minute. Let me show you that if I want to change any particular value, will I be able to change that or not, right? Now let's do one thing. Let's change the marks value at 4th index only. And let's say now the 4th student has a marks of like 99 only, right? Now he don't have a marks, 50 marks. Now he has 99 marks, right? What happen if I run this? What will be the answer according to you? The answer will be 99, right? Why 99? Because we have overridden its value, right? Initially it was 50, now it is 99, right? So this is also a thing, and now you can also see that this is a very simple task, right? This can also be done in O1 time. Now inserting and deleting is O(n) time, right? Why O(n) time? I've already told you this. Just a minute. See, let's take this example. Let's redo. Let's undo this. Right. So whenever we talk about time complexities, we talk about the worst case scenarios, right? Worst case scenarios, mein, what could be the worst case when I'm deleting any element? Worst case could be if I will delete the first element. If I'll delete the first element, I'll have to shift all those elements one step ahead. I'll have to shift it. So technically, I'm shifting all the n-1 elements, right? So that is why you can see that shifting or insertion. Just a minute. Sorry, deletion is a what? O(n) time complexity task. Now, second thing could be what? The worst case scenario of that could be what? If I am inserting any element, what could be the worst case scenario? What scenario could be? I'm inserting at the first place itself, right? Again, if I insert at the first place, what I'll have to do? I'll have to shift every index to a next step. Now you'll say ki, what will happen if if I have one less space, right? If I have the 5 space and I've already given all these 5 value, what will happen if I try to rearrange that? So in that scenario, you have to reduce one value, right? Obviously, if you have 5 space and if you are inserting one more element, you have to reduce one element, right? So the last value will be reduced and all these value will be placed afterward. Again, you can see we are again pushing all these n-1 value. So that is why insertion is also a what? O of n task. Right. So this is about arrays, right? I hope everything about array is must be clear to you by now, right? And if these things are very, very clear to everyone, although was not much to deal with it. Now, if these things are very, very clear, then we can directly jump into our sorting algorithms, right? And see, these things are very, very important. These are super important because, many of the developers or many of the coders till date don't know the exact difference between the insertion sort, merge sort, bubble sort, etc. and what are the basic functionality of it. Right. And also one more thing is ki will not be seeing the code of it, right? Why not code? Because see, you can do insertion sort, you can do merge sort, you can do bubble sort, all these sort using simple for loops and if else statement, right? But when it comes to like merge sort, when it comes to like what you say, quick sort, all these things, doing all these things require your knowledge in recursion. Right, so that is why now again, if I start explaining recursion on this class, then it will be a very long class. And even before starting these sorting algorithms, you need to know the simple problems on recursion. Right, so I'll only explain you how these functions or how these algorithms work internally. Right, till then I believe that everyone is clear with our arrays and all other concepts with it. Right. If everyone is clear with arrays and if we can jump with our sorting algorithms, do give me a thumbs up. Quickly. Yeah, hello Anjum. Sorry. Yeah, hello Anjum. Akandar. Yeah, if I'm pronouncing your name correctly. Quickly, give me a thumbs up. And also, till this point, if you are learning or if you are enjoying these things, you can give this video a like and you can subscribe to the channel obviously, and you can share this with your friends as well. Okay. Yeah. Cool. Give me a thumbs up quickly if you have enjoyed this and if you are ready to start with the next part. Cool, great, Roshan. Chalo, let's head back to our notepad area and now let the fun begin. Right? Why I'm telling you this as fun? Because these are very important. Just a minute. These are super cool as well. Chalo, cool. Also, you can like the video because obviously we are learning something, and you guys, I feel, are also enjoying it, right? So when we talk about sorting algorithms, now sorting algorithms may basically will cover these sorting algorithms in 2 groups, right? What 2 groups? One is the bubble sort. Second, we'll say that insertion sort will be there. Third will be what? Selection sort, right? And don't worry about the attendance, like okay, thanks, happiness, if you are learning this. I mean, if you are enjoying this, right? And in the second group, and don't worry about the attendance group, attendance link and all. That will be shared, just at the end of the session. Please make sure that you are, giving your 100% attendance. I mean, 100% attention over now, because these things are very, very important, and these things are very, very relative, right? Very logical as well. So we'll look about merge sort then, and then at the end, what we'll learn about the quick sort. Right. Chalo, cool. Now let's start with the very first sorting algorithms, right? The very first sorting algorithm that we have is a bubble sort, right? I'm keeping that aside because, or maybe let's keep that aside only, and then let's start over here. Cool. So with bubble sort, what happens with bubble sort? For example, I'll be taking one array or something. Let's take another color because this color is not looking very cool. Yeah, let's take this color, or yeah, let's take this one. Now what will happen is we'll write some number, right? Maybe let's write 5 or like, let's take this example. And what we'll be doing is we'll be discussing, or we'll be we'll be explaining all these things with this example only, right? Suppose this is our array. Now, it is not like that ki our sorting algorithms will work with only these numbers, right? It will work with every number, but for a simplicity, so that you can relate ki, acha, what was different with the bubble sort, what is different with selection sorts. That is why we'll take this simple example. And once we have a whole understanding with it, then we can take many other example, and you guys can also suggest ki, acha, sort this or sort that, and then I'll explain ki how this is working, right? So before starting bubble sort, right, bubble sort may, the main funda or the main scheme of bubble sort is ki you take one element, right? You take this element, maybe let's take another color, right? You take this element and you compare it with the next element, right? The catch over here ki compare with the next element, compare with adjacent, right? See, you can summarize this bubble sort in just one sentence, right? Key bubble sort does what? Bubble sort compares with the adjacent element. Now, if this compares with the adjacent element, then how it is working, right? So what we'll do is we'll take these two elements, right? One thing I want to make sure here is key we are arranging all elements, or we are sorting in the ascending order, right? Now, okay, you can do that for descending order, you can do that for any other order or something, right? We are considering only ascending order, right? Right, it's again not the thing ki bubble sort only does the sorting in ascending order, right? You can do it in descending order as well. Okay, so now we are doing it in ascending order. What bubble sort will do is it will take these values and it will check ki acha, which value is smaller than which value is smaller. 4 is smaller, obviously, right? So what we'll do is we'll place 4 over here and we'll put 5 over, right? First comparison will happen between these two. It will pick it. Whatever value is the smaller, it will start placing it here. Now the catch over here is ki every time whatever is the larger value, what will happen is ki bubble sort will take that value only and it will start comparing it with the next value, right? Now since that value is swapped, right? Now we have 5 over here, we have 4 over here and 5 over here. What will take? 5 is again taken and now 5 will be compared with 3, right? These two values will be compared. Just a minute. Let me remove this part. Let's write it similarly. Yeah. Now what will happen is 5 and 3s will be compared. Which value is smaller, 5 or 3? 3 is smaller, right? So what we'll do is we'll replace this. We will say, acha, 3 is here, 4 was already there, then we have 3, and then 5 will be placed over here, right? I hope you are getting this, everyone. Okay. If this point is very, very clear, then the remaining thing is also very simple. Now, we have replaced this, and now what we are remaining with? We are remaining with 5 and 2, right? Again, what will happen? This 2 will be compared with this 5, right? Which one is smaller? Again, 2 is smaller, obviously. So what will happen is this 5 will be replaced and 2 will be there, and then 5 will be replaced over here. Every time what we are doing is we are swapping those values, right? How the swapping is working, you know, how this value is comparing, that is a different part. The only thing is how the bubble sort works internally, right? This is what we need to do. Now this is compared out, right? Now what will happen? Again, we have 5 and we have 1. Again, which one is smaller? 1 is smaller, obviously, right? So these things, first of all, these things will be compared. And since 1 was smaller, so 1 will be placed over here and 5 will be placed over here. So after round 1, what will be our array? This is round 1. Round 1 ke baad, we will have 4, 3, 2, 1 and 5. Everyone, are we clear at this point? Will this be our resultant array after round 1 or not? Tell me quickly. See, I want your interactions, right? I want your answers. Only then I'll know na ki you are getting or not. Else I'll keep on explaining. Okay, quickly give me thumbs up or something so that I can understand ki you are learning. You are understanding basically. Right, I hope everyone is getting. Now let's take the round 2 of that, right? In round 2, what will happen? Again, the similar thing will happen, but please note that this is a very important thing that you will note here. Keep the largest value of our array is at the last. Largest value is here. Now we will not compare, I mean, we will not do the bubble sort for our last element, right? Why we will not compare till the last element? So all these things that you are writing now, is that for what? The doubt, or is that you are not getting it? Again, if you didn't got the first round, don't worry, right? Stay with me for this round second, then you'll know in a better way. Also मैं एक बार हिंदी में भी explain कर दूंगा, कोई problem नहीं है, जिसको problem हो रही है समझने में, या तो let me do one thing, मैं एक बार हिंदी में explain करता हूँ इस चीज को, ठीक है? तो देखो अभी तक क्या हो रहा था, हमारे पास हमने सपोज कर लो 5 4 3 2 1 एक एरे ले लिया है, ठीक है? अभी जब बबल सॉर्ट होता है, बबल सॉर्ट को ना मैं एक ही लाइन में कैसे डिफाइन कर सकता हूँ? मैं बोल सकता हूँ बबल सॉर्ट क्या करता है, बबल सॉर्ट क्या करता है कि बबल सॉर्ट क्या करता है, आपका नेक्स्ट एलिमेंट से कंपेयर करता है और देन आपका जो भी है सॉर्टिंग कर देता है, ठीक है? सिंपल वन लाइन आंसर ऑफ दैट. नाउ इस अगर सॉल्यूशन में आप देखोगे तो यहाँ पे हो क्या रहा है, इवेंचुअली क्या हो रहा है कि आपने पहली वैल्यू ली, जस्ट अ मिनट, वेयर इज दैट पेन नाउ, वेयर इज माय पेन नाउ, या नाउ यू कैन सी व्हाट कि पहले आपने 5 लिया, ठीक है, और 5 और 4 को कंपेयर किया. 5 और 4 में से छोटा कौन सा है? 4 है. तो आपने क्या किया, 4 को इधर रख दिया और 5 को यहाँ ले आए, ठीक है? ये किया ना आपने, इसको स्वैप कर दिया और 5 को ले आए. अगेन जो बड़ी वैल्यू आपने इसको पकड़ के रखा, देन आपने इसको नेक्स्ट वैल्यू से कंपेयर किया. 5 और 3 को कंपेयर किया तो स्मॉलर कौन सा है? 3 है. तो आपने 3 को यहाँ रख दिया, 5 को इसके प्लेस पे ले आए. अगेन अब यहाँ पे 5 पड़ा है तो 5 और 2 का कंपेरिजन होगा, राइट? ये देखो नीचे जो भी लिख रहे हैं ना, ये रिजल्टेंट एरिया हमारा, तो 5 और 2 का कंपेरिजन होगा. तो अगेन 2 छोटा है तो 2 को यहाँ रख दिया, 5 को यहाँ ले आए, ठीक है? अब अगेन 5 और 1 का कंपैरिजन होगा तो 5 और 1 में से छोटा कौन सा है? 1 छोटा है तो 1 यहाँ आ गया, 5 यहाँ पे है, ठीक है? तो राउंड 1 के बाद देखोगे तो आपका एरे ये बन जाएगा 4 3 2 1 5. इस चीज में ध्यान रखने वाली बात ये है कि जो आपका लार्जेस्ट एलिमेंट होगा एरे का, वो सबसे लास्ट में पहुंच जाएगा आपका, ठीक है, हमेशा. और अब हमने जब राउंड 1 कर दिया है तो हमें ये दोबारा चेक करने की जरूरत नहीं है. क्यों? क्योंकि ये ऑलरेडी सॉर्ट हो चुका है, सबसे लार्जेस्ट एलिमेंट हमारा एंड में आ चुका है, राइट? तो ये आई होप कि सबको समझ में आ गया होगा. चलो अब इसके आगे चलते हैं. अब आगे बहुत ही सिंपल है, जो चीज़ हमने ऊपर करी है वही चीज़ नीचे दोबारा से रिपीट करेंगे. नीचे क्या करेंगे, इन दोनों में से वैल्यू कंपेयर करेंगे. छोटा कौन सा वैल्यू है इसमें से? 3 छोटा है, तो हम लोग क्या करेंगे कि इसको और इसको कंपेयर करेंगे. इन दोनों में से छोटा है 3 है, तो 3 को इधर रख देंगे और 4 को इधर ले आएंगे, राइट? इन दोनों को कंपेयर किया, 3 छोटा था, 4 इधर आ गया, स्वैप कर दिया दोनों की वैल्यू. क्यों हम इसको छोटे वैल्यू को पीछे रख रहे हैं? क्योंकि हम इसको असेंडिंग ऑर्डर में ले जाना चाहते हैं, ठीक है? अगेन अब 4 और 2 का कंपेरिजन होगा इधर, राइट? 4 और 2 का कंपैरिजन होगा तो 4 और 2 में से कौन सा छोटा है? इसलिए 2 छोटा है. तो हमारा यहाँ पे 4 आ जाएगा और यहाँ पे 2 आ जाएगा. तो 3 2 4 चल रहा है हमारा एरे, ठीक है? अगेन इस 4 का और इस 1 का कंपैरिजन होगा. 4 और 1 में से छोटा कौन सा है? ऑब्वियसली 1 छोटा है. तो इन दोनों में से यहाँ पे 1 आ जाएगा और यहाँ पे 4 हो जाएगा, ठीक है? अगेन 4 और 5 का कंपैरिजन होगा, बट नहीं सॉरी, हम लोग 5 तक नहीं जाएंगे. क्यों? क्योंकि 5 तो लार्जेस्ट है, राइट? तो हमारा सेकेंड राउंड भी कंप्लीट हो गया. सेकेंड राउंड के बाद हमारे एरे क्या बना है? हमारे एरे बना है 3 2 1 4 5, राइट? ये हो गया राउंड 2. राउंड 2 के बाद हमारा ये एरे बना है, राइट? अगेन इसमें अगर आप नोटिस करोगे तो ये दोनों हमारे लार्जेस्ट वैल्यू हैं एंड हमारा एरे भी सॉर्ट होने लगा, राइट? If I have to explain this in Hindi, let me do that quickly. What we were doing is, if we run this round again, we'll compare 4 and 3, right? In 4 and 3, what will happen? Since 3 is smaller, so 3 will take place this, and 4 will be here. Again, 4 will be compared with the next element. What is the next element? 2, right? Again, 2 is smaller than 4, so 2 will be placed and 4 will be replaced over here. The same thing will happen. 4 is compared with 1 again. Again, 1 is smaller, so 1 will be placed here and 4 will be there. 4 और 5 का comparison, I mean, we'll not compare 4 with 5. Why? Because 5 was the largest element. There is no need of comparing 4 and 5 now. Although if you compare it, there will be not be an issue, right? Then what will happen is 4 and 5 will be placed over here. After round 2, what will we have? We will have this array, right? Again, if you do this step again and again, right? If you do this repetitively, what will happen? Now I will do this very quickly because I don't want to waste the time over doing the same and same. Now I will do one thing. I'll do compare over this, right? In this 2 is smaller. This will be compared, so 3 will be placed over here. 3 is now compared with 2. 3 is now compared with 1. What will happen? since 1 is smaller, so 1 will be replaced over here, 3 will be replaced over here, right? 4 and 5 though already were there, so there is no need of doing that. Now you can say that after round 3, what is our final array? Round 3 ke baad, we don't we have this 2, 1, 3, 4, 5? And if you again look at it closely, all these things are largest in my array. Largest values. Right. Cool. Now, again, the next step is very obvious, right? Can you guess it or not? I hope everyone will guess it. Now, the final answer will this. We will compare this and boom. 1, 2, 3, 4, and 5. Is the array sorted or not? I hope everyone will say if this is sorted. Sorted. Cool. So we have sorted the arrays by just applying our attendance link. Just a minute. In the last 5 or 10 minutes, I'll share it. Don't worry about that. Please focus on your learning now. Okay, so this is how it is sorted. Now let's go to the next version. Right now, let's see the next part. I hope this is clear to everyone. Now let's take another example. Right? What example we will take? We will take the example of what? No, we will not take another example. We will take another sorting algorithm, right? Don't worry, I'll explain all these things with another example. I'm not taking example right now because obviously we don't have that much time right now. We can discuss every example. So I'll write what was the next sorting algorithm. The insertion sort was the next algorithm, right? Was the next algorithm. So I'll write, just a minute. Write insertion. In insertion, the basic intuition is we divide in. Just a minute. Let's take another pen. Divide in sorted and unsorted. Yes, right. Boleto, what do I mean by that is, suppose if you have an array, right? If you have 1, 2, 3 values, you'll make a partition over here. You'll say, this is my sorted array. You'll say, this is my non-sorted array. Right. So this is non-sorted. You'll pick a value from here and you'll place that value on its correct position in the sorted element, right? This is the one word or a one sentence explanation of that, right? Now you'll say, how do we do that? What is the method of doing that? Don't worry, I'll explain this with an example. Again, what we'll do, we'll take the same example over here as well. We will say what? We will say our array was what? 5, 4, 3, 1 or 5, 4, 1, 2, 3. 5, 4, 1, 2, 3, right? So let's take the same example over here also. 5, 4, 1, 2, 3, right? This is suppose our array. Now what will happen is, let's take this different color now. Let's take this one. Now at every step, what we will do is, we will first of all we'll say this is our sorted array. We will say until this point we have a sorted array. Although this is not sorted. Yeah, although this is not sorted at this moment, what will happen is, don't worry, all these questions that you are asking now, do we have n-1 iteration where use comparison operators for compare? Yeah, comparison operators will be used to compare the values, right? Okay, so at this point we will say this is our sorted point and this is all is our unsorted array. Now what we will do is, we'll take one value from the unsorted array. We'll start from the immediate next value after the sorted array. We will take this value and we will see what is the right position of this value in this sorted array, right? What do I mean by that is, we will say, this 4 value is smaller than 5, right? So what will happen? What should be the effective answer of that? The effective answer of that could be 4, 5, and then we will have a break. And after that, what we will write? We will write now the rest of the values are what? Now the rest of the values are 1, 2, and 3. Right, so this is again our sorted value, our sorted array, and this is our non-sorted or unsorted array. Everyone, is this clear or not? Now, this might feel very obnoxious to you at this moment. Let me take another example. Let me complete that and then you'll get it properly. Now, for the next round, what will happen? See, in the next round, we will take another value from here, right? We will pick up this one value and we will say, let's try to put this value at the exact spot. Right, we will compare this value with 5. 1 is smaller than 5, right? So it should be placed before 5. So 1 will be placed here, but 1 is also smaller than 4. So instead of placing it over here, what we'll do is we'll place it over before 4 because 1 is also smaller than 4. again, if there is no value before 4, what we'll do is we'll place it here. We will say 1, 4, 5, and then we'll say, yes, this is our sorted array, and rest is the unsorted. 2 and 3 are the unsorted. Right, so this is our sorted, this is our unsorted. Cool, everyone. Now for the next round, what we will do is, just a minute, let's move. Let's move below and let's do the demonstration over here. Now for the next round, is this, yeah. Now I'll scroll this over here and I'll place my pen and I'll say A. Again, the value was sorted, right? 1, 4 or 5 are there. Now we'll pick up 2 from here and we'll try to push it in the perfect spot. 2 is smaller than 5, exactly, so we can shift it over here. But again, see, 2 is also smaller than 4, so we should shift it over here. Again, if we'll check, again we will try to check if 2 is also smaller than 1. No, right, 2 is not smaller than 1. So what will happen is 2 will be placed over here. So what we will do is we will replace those steps and we will say key, instead of placing it over there, we can do 2, 1, 2, 4 and 5, and this is again our sorted array. And in our unsorted array, only 3 is remaining, right? So this 3 is only remaining and this is our unsorted array. Again, we will make the next round. We will make the next round. In next round, what will happen? We will again put this 3 value over here and we'll check if this is smaller than 5 or not. Again, it is 5 smaller than 5. So we can place it over here, but we will not place it over here because 3 is also smaller than 5. 4. So we'll place it over here, try placing it over here. We will check if this is smaller than 2 or not, right? So this is not smaller than 2. So what we'll do is effectively we will write one thing, 1, 2, 3, 4 and 5, and in this manner this whole array is sorted. You can try any other method, right? Let me write that with another pen so that you understand that this is sorted, right? So now this is sorted. Everyone, are we getting till this point? I hope that everyone is finding it comfortable. Don't worry, man, Satyavan and all. I'll give it to you the attendance rate. Right, just one more sorting algorithm. I mean, there are 3 more sorting algorithm. After explaining one more, I'll give you the attendance rate. Right, please be with me. Chalo, cool. Now let's take the next sorting algorithm. I'll wrap it up very quickly. Don't worry, I'll not take much of your time. Right, now we will take one array. See, the main agenda is you should be clear about all the sorting algorithms, right? Attendance it is a secondary thing, right? We'll write what? We'll write selection sort over here. In selection sort, what we can say is finding the smallest first. Right, I can explain, I can define selection sort in one line by writing finding the smallest first. Right, finding the smallest first will mean what it will mean. Suppose we have a same array, right? 5, 4, 1, 2, 3. Right, now what we will do is we will go in this array and let's take another pen for this moment, right? Let's take green for now. And what we will do is we will iterate our arrays and we will find out what is our smallest value in this array, right? If you go through this array and you can find out 1 is the smallest value, right? So what will happen? We will replace this value. I mean, we will place this value at the very first index, right? This is almost similar to the first one, right? The only change is we will iterate over the whole array and we'll find the smallest value over here and we will fix it over here and we will replace this value now. Now what will be our effective array? 1 will be there and all the remaining things will be 4, 5, 2, 3. Okay. Now we will again move the array, but from this after this index. Why after this index? Because this is the smallest array. This is the smallest value. You can say smallest value is here now. After this is done, what we will do is we will again traverse this and we will find out which is the smallest value. This is the smallest value, right? So what we will do is we will replace this with the next value. And what will be our effective answer now? Our effective answer will be 1, 2, 5, 4. Oh, just a minute. Let's write that with next other pen so that you know what is the sorted index now. 1, 2, 5, 4 and 3, right? Everyone, are you getting this? Every time we are selecting the smallest element from the remaining ones, right? Why remaining? Because these are already sorted now. I will say these are the smallest now Okay, after this, what we will do? You guess it, right? You guessed it. We'll traverse and we'll find the smallest value. What is the smallest value? 3. We will replace it over here. And what will be our answer? 1, 2, 3. And what will be the next value? Next value will be, just a minute, 3 will be there. So will be 4 and there will be 5. Right, everyone? This will be the next answer, right? Again, if you find out these are the smallest one, but if you again try to compare, these are the already sorted one. So can I say that this is also sorted now? Right, so this is also sorted using what? Using the selection sort. The only key over here is to find the smallest one and place it in the first index, right? Start placing it from the start. Okay, so this is about the selection sort. Everyone, are you getting this? I hope everyone is getting it, right? Because, yeah. Now, since everyone is asking for attendance link, just let me, for a moment, let me give it to you. Right, let's do that. Let's paste it over here. See, these are very important things that I'm teaching you right now, because I'm just giving you the simplest explanation, simplest possible explanation with the help of this. No, this will not be a very comprehensive course, since this is a 7-day course only. That is why I'm only telling you the telling you all the like algorithms only, right? That is why I'm not giving you the whole like, what do you say, the whole code and all, right? I'm not going into that because in 7 days it is not possible to do that, right? Quickly, let's go with the next point, right? These are the trickiest one. These are the trickiest one that we call as quick sort and merge sort, right? I am hoping that everyone will not get it, because you'll need to know a bit of recursion concept and all, but don't worry, I'll try to make sure that everyone here at least understand what is the merge sort and what is a quick sort, right? So merge sort. Merge sort is a very cool example wherein I can say ki split and merge back. Split and merge back. I can explain merge sort in one simple statement that says split and merge back, right? Let's again take that example, same example. Wherein, yeah. Now we can say what was our array? 5, 4, 1, 2. Let's do one thing. These are odd numbers. Now let's take even number now, because although we can do that with odd numbers as well, but you might get confused whenever we'll talk about odd numbers, right? So the only catch over this is, see, this is simplest one. What you have to do is, let's take this another pen over here. Maybe let's take blue for now. Let's take orange, right? So what is the catch over here? You divide the array into half, right? This is the half one, N1 you can say, or ARR1. This is the N2. What you'll do is, you'll separate these arrays and you'll say ki this array will be separated. I mean, this array will be sorted out in itself, right? You will say ki 4, 5, 6 will be my output. And you will again say ki this array will be sorted out again. 1, 2, 3 will be my output. Right, everyone. Now you might feel ki, how will this array get sorted in its own, right? How will we sort 6, 5, 4, or how will we sort 1, 2, 3, right? This is a mystery for now, right? If you know about recursion, you would have easily guessed it how we will sort this, right? But for a moment, let's understand that this is sorted now. This is sorted now. This is also sorted, although that was already sorted, but yeah, this is sorted. Now, if we have sorted all these arrays, right, differently, right? This is sorted and this is sorted. What we will do is merge them back. Merge back. Now, merging is a difficult task over here, right? You cannot just directly push them side by side. You cannot just say, ki write 4, 5, 6 and 1, 2, 3. 4, 5, 6, comma 1, 2, 3, right? If you write this, what will be the use, right? This will not be separate. This will not be sorted, right? So to do that, what you will do is, you will compare these value. You'll put a pointer over here. I mean, just say ki you'll put some arrow over here. You'll check ki what is the smaller value in 4 and 1, right? You'll put this in a new array and you'll say ki, 1 is the smallest value, so I'll put it over here. Then since once is once is removed from here, then this will point to 2, right? Now again I'll check ki 4 and 2 so what is the smallest one? 2 is the smallest one, so I'll write 2 over, right? Please note over here ki why we are not picking 4. We are not picking 4 over here because 4 is not the smallest one. And why we are only taking these values? Because these values are the smallest one. And as soon as we take one value, we will push it out. I mean, we will remove this from the array, right? Now we will take 2 and 2 is also removed. Now we will take this arrow to the next point, and again we will check if this point is and this point is what is the smallest one. 3 is the smallest one, so we will push back 3. Again, since this array is finished now, so what we can do is we can easily copy this at the end. Why we can easily copy this? See, these is also sorted in its own, right? This array was also sorted in its own, and this was also sorted in its own. So once this array is vanished, so we can say that all these are in the right order, so we can easily merge it in this way. We can write this is our sorted array, right? Now this might not sound very clear to you, right? You'll say, you'll again start asking how is this merged, how is this already merged, right? How is this sorted basically? So if you know a little bit of recursion, then it would be very easy task for you, right? If you don't know, let me give you a glimpse of that, right? Again, I do not expect everyone to get this because this is a relatively trickier one. Just understand it this way. If this is again our array, what we will do, we'll again bifurcate it. We'll again say 4 is now and 5, 6 is the other part. We will again say, see, if we have only one element, so single element is always sorted, right? If we have 4 and we'll say sorted, so 4 is already sorted. If we have 2 elements, what we will do, we'll again bifurcate it. We will again say 5 and 6 are the elements. Now, if we have 2 sorted arrays, what we will do is we will merge them back. We will merge them in an order that these get sorted out. If we merge them back, then the merged value will be 5 and 6, right? We will get 5 and 6, and then we have another value that is 4. Now again, we will try merging it. If you try merging it, the correct order of merging will be 4, 5 and 6, right? So that is why, sorry, I did one thing wrong. Sorry. I started explaining the same thing. I started explaining the same sorted array. Just a minute. Let's see with this point. Sorry. It's my bad. Yeah. Let's take this pen, or let's take this pen. Now, see, 654 was our array, right? So 654 we will bifurcate it in 6 and then 5 and 4. Now what we will do is, since 6 is already sorted, so we don't break it further. We will break it further in 5 and 4. Okay, and then we will say, since these are already 1 now, so these are sorted. Now merge them back, right? While merging, we know we merge them in such a order that the resultant gets sorted out. So if we merge them, we can say that our effective answer will be what? 4, 5, right? And if this is the sorted one, we will again merge this with this one. And if you try merging it, the effective answer will be 4, 5, 6. Everyone, this is how this works internally. Although there is no need of you to understand it, how it is working internally, because you'll get this clear once you know the recursion, right? So I do not expect you to know this, how this is working, right? The only thing is that you need to know is you'll split the array in 2 halves, then you'll merge them back, and eventually you'll have the merged array. You'll have the sorted array, right? I cannot explain it more further because it will take more time, and second thing is you'll not get it until and unless you know recursion, right? Everyone, are we getting it? Are you getting this or not? This might be a little tricky, but trust me, this is how it works. More functioning will be clear once you know the recursion. Yeah, exactly, Ganesh. N by 2 formula, yeah. For the quick sort, quick sort we will not take n by 2, or we will take the pivot point, right? We'll separate it with pivot. Everyone, are we getting this? Just 1 more minute, 2 more minutes, and I'll quickly explain this quick sort, and we'll wrap up this session. Quick sort will again require your attention over recursion, right? If you don't know recursion, then it will be a little tough, but yeah, it's not impossible. So quick sort, what we'll do is pick an element, and place all smaller values on left of it and larger value on right of it. What does this mean is let's take the example and let's see what does this mean. 6, 5, 4, 1, 2, 3. Right. Now what we will do is we will let's take another color. Let's take this one, right? This one looks good. So what will happen is we will first of all select any element, right? Generally we select the last element, right? And we say this is our pivot element, right? What do you mean by pivot, right? If you have learned physics, if you have studied physics, pivot is basically a point, right, from where the motion happens generally. So you can say we have 3, right? What we will do is we will place 3 in such a position that, suppose this is our pivot, right? This is our pivot. What we will do is all the values smaller than 3 will be there. All the values greater than 3 will be there. If you do it this way, again, this is not the case ki, acha, you will say ki, acha, this will always get sorted out in one step, right? This will not happen, right? Let me tell you why this will not happen. See, what are the smaller values than 3? Tell me, quickly tell me this. 1 and 2 are the smaller values, right? Yeah, pivot element, yeah. So 1 and 2 are the smaller elements, so we'll pick them directly, right? Directly means we will not change their order. We will not say, acha, let's place 2 first or let's play 1 first. We'll quickly place them over here and we will say what? 1, 2, and then since 3 was our pivot, so we will write it there only. And what all values are greater than 3? Let's take another pen maybe. 6 and 5 are the 6, 5 and 4 are the larger values than pivot, right? So we'll place them directly over here, right, without even changing their order. So we'll write 6, 5 and 4. Right. So these are the smaller values, these are the largest value, this is the pivot. Right. So this is step 1 for us. Now we will repeat the same step. How will we repeat the same step? Just a minute, let me show you back. We will repeat the same step and we will say, acha, now let's check the pivot. What is pivot for us? 4 is pivot, right? Why? Because, acha, just let me write that first. Let me get the modified array now. Right, this is the modified array now. Again, we'll check the pivot. Pivot is generally we take the last element. Again, we'll take 4 over here and we'll write all the values smaller than 4 over here. How do we write? 1, 2, 3 are smaller, so we'll write all these values here. 1, 2, 3, and all these values are larger. What we'll do is, sorry, just a minute. All these values are larger, so we'll put them over here, 6, 5. Right. So now the array started almost sorting out. Right. If you copy this again, 1, 2, 3, 6 and 5. Again, these are not sorted right now. So what we'll do is again pick up the pivot element. This is the last element. We'll put it in such a way that all values smaller than 5 are on the left and values greater than 5 are on the right. We'll do one thing. All these values, which all are the smaller value. These value 1, 2, 3 will be there. Then there will be, sorry, 4 was also there, right? I missed writing a 4. So what will happen? 1, 2, 3, 4. 5 will be placed over here because 5 was a pivot element, and what? 6 will be there, right? So if you look at it closely, can you not say that this is sorted now? Right? How this got sorted? Just because of our pivot element, right? So we will proudly say that we have sorted this with the help of what? With the help of quick sort. I hope everyone got this thing clearly. This is sorted. Right, so these all are the different sorting algorithms that we have. Right, these all are the, okay, now someone wants to sort any particular element, right? So before even starting that, right, let me tell you all these sorting algorithms are done now, right? So almost our agenda is done. I mean, all the things that we need to cover. Now some people are saying, yes, sort this or sort that. Let's quickly take this up, right? So I want to sort this. From which algorithm you want me to sort this? I'll quickly show this demonstration. Then only you will say, na, ki, array, you have sorted it with this, you have sorted it with that. I want the sorting with that. I'll quickly sort it for you. Quickly, 1 or 2 more minutes. I don't want to waste much time now. Let's sort with this with quick sort, or what? Quick sort will be okay, or what? Chalo, let's start sorting with quick sort now. If you're not responding, I mean, although there will be a lag. So can you take this in code manner after that? Right now, though, it will not be possible because the timings are little constrained because I have another class to attend. I mean, I have another class to take, by the way. So I'll not be able to code it right now. But and also since the webinar is very limited days we have, so we'll not be able to do the code demonstration right now. Yeah, but if you've come across any doubt in the code, you can maybe escalate that to team, and someone from the team will take that doubt to me, right? Because I cannot take that doubt directly right now. Okay, chalo, let's sort that quickly, and then quickly let's take the pen now S through number taken. Sorry, S through S tough number taken. Achha, I mean tough number na. So tough number mein someone has given me this only. Let's try with that only and then let's see. Code, so you can get it easily from any coding platform. I mean from any platform like GFG or something, right? I'm not focused about code right now. 12:17. Attendance link I've already shared. Just let me share it for a moment. And also, see, if you enjoyed anything, if you liked this session, please do give a thumbs up. First of all, please share this video with your friends, right? Because the thing is that we will get motivated, right? So then we'll take more such sessions for free, first, by the way, right? And second thing is, ki, you know, if you enjoyed something or if you enjoyed the teaching or way or something, you can, you know, quickly tell that in your feedback forms, right? So that I feel motivated. Chalo. And you can obviously share that with your friends. Ki, okay, I know about this. I learned sorting algorithms from there, and you can also try it. Right, 12, 17, 18. I'll quickly sort this area and then we can wrap this up, right? Because it's already, you know, some minutes past. So, I mean, the original time. 12, 17, 18, 13, 2, and 1, right? This is our original array, right? Cool. So let's sort this with pivot. I mean, let's solve this with quick array, quick sort or what? Let's take the quick sort element now. Although if you want me to sort with any other algorithm, I can also sort that. I mean, I want you to try that, right? Because this will, I mean, every algorithm will work the same way that I've told you, right? It's not like it will not work for any particular number. Now, let's quickly do one thing. We'll take the pivot element as last element and we'll place it in such a way that all the smaller elements are on the left hand side and all the, you know, larger elements are on the right hand side, right? In this situation, you know, I mean, you can see that one is the smallest element. So that is why let's take this different color because this color is not visible. Let's take this now. Yeah, I'll fix this over here. I'll write it then. And what I'll do, I'll write all these numbers that are larger than it in the same manner, right? 12, 17, 18, 13, and 2. Cool. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Cool. Now let's do another thing. Let's take the pivot element as 2 now. What will happen? All the values smaller than 2 are already there, right? So just a minute. I'll write 1, 2 over here. And similarly, all these values will be copied down same exactly over here. 12, 17, 18, 13. Cool. Again, let's take the last element. 13 we will take. We will write 13 in such a way that all the values smaller than 13 are before that and all the values greater than that are after that. So we'll quickly take 1, 2, 12 is also available. 12 and then 13 is our pivot element and all the values greater than that are 17 and 18. Cool. This is the pivot. This is the pivot now. This is 18 by now. Again, let's take the pivot as 18 and 18 may you can also see that 18 is already at its correct position. So what we will do, do one thing. Just a minute. Let's erase the pen. Yeah, we have 1, just a minute. 2 was there. We have taken. Okay. Oh, just a minute. One thing 2 was there, right? Immediately after that, we took 13. 13 was correct. And just a minute, 13 was there. So all the values greater than that are after that. And okay, chalo. So 1, 2, after that 12. After that, what 13 was already placed, and 18 was placed, right? Yeah, so this is sorted now. I am doing this again and again, right? So now you know that this is sorted, right? This is the sorted array. Sorry, I forgot. I missed that part. This already got sorted, right? So this is sorted. If you want to try this with any other method, you can also do that. Okay? So this is how it is done. And yeah, this was all about sorting algorithms and all. Now, there is one other slide in our PPT, right? That says key. What are the different, see, all these are the definition and all of written that, right? I have not gone through it because I want you to explain that on paper. Now there is a time complexity of that, right? So I'll not go into depth right now because we are running late on time. So go through this table and you'll get this key what I was trying to say, right? So that was about the session. Yeah, that's all. And I hope you have enjoyed something and you have learned something. And yeah, it should be, I mean, it would be helpful for you. So if this was helpful, please do like it, please do subscribe, and please do share it with your friends, and please do share your feedbacks. And till then, we bye bye. We'll meet tomorrow at the same time at 6, and we will move with our agenda. Right. So bye bye everyone. If you come across any doubts or something, you can comment in the videos, or you can ask that in your groups. Right. Chalo. Bye bye everyone. Have a nice day. Keep running all day, all night.